Hello guys, welcome back to Code. In this video, we are going to discuss about a project that is gold price prediction. The first step is to import all the required packages like pandas, numpy, matplotlib, seaborn, and sklearn. Let's import all of them. Import pandas, spt, import numpy, snp, import matplotlib.pyplot, spld, import seaborn, sns, and then I have to import few things from sklearn. Let's do that in the lateral parts of this video. Let's run this cell first. After running the cell with basic import statements, this is the data set I will be using in this project. So this data set has data of date, SPX value, gold value, USO value, and silver value at last, euro to USD conversion rate. Right. So I have this data from 2008 to until 2018. Right. So let's import this data into our Jupyter notebook. To import the data, you have to use pandas like pd.read csv like that, and give the file name. It is gld underscore price underscore data.csv like that, and I will be storing this in a gold price variable, the data. Right. Let's run this cell. Let's visualize this data here. Let's see this data here using .head gold price .head like that. It will print first 5 rows of our data set. So as I have shown in this CSV here, the same data appears here, but here it only shows 5 rows. So let's have some pre-processing on this data. Right. Let's understand this data more clearly. Before that, if you observe this date value, it is unique to every row, right? So this might not be useful for my analysis or my prediction I will be doing here. So first of all, I can drop that date column. So we can do that using gold price dot drop. So using dot drop function, we can do that. I have to give the column name date like that, and I have to give the axis as 1. So it will drop the date column from our data, and I will be storing this new data in the same variable. So without any confusion, I will be storing the same variable like that. So if you want to see the data, you can see again .head. It is same, right? Except it doesn't have date column. And then let's see some information about this data. We can use .info method, .info like that. So it shows what are the data type of those columns, right? All those columns are having float 64 data type. So those columns are all of numeric data types, right? So we don't need to do an extra pre-processing work where we have to convert an object or string to numeric type. Basically, this might not be the same for all other cases. So some variables will have a type of object and a type of string. So there might be a case where one variable is string and we have to pre-process it using one hot encoding, and we have to pre-process the object to string or object to number like that, but we have to convert every data into the numeric format. Then only we can feed it to our model, right? So in this step, we don't do any pre-processing because we already have numeric values, not the object, not the strings. Okay. So next step is to check for any null values. So gold price dot, the method we use here is null. This function, what it does is it will take the data set and search for null values. It will check each row, each value, and says whether it is a null value or not. If it is null, it will return true. If it is not, it returns false. And we just sum all the true values here. So we'll add up all the true values of that specific column. Then I'll be displaying them here. Let's see. So in this case, we don't have any null values. It is very clean data, I hope. So we don't get any null values here. It is all zeros here, right? So let's see some other information here using .describe method. Describe like that. Let's run it. If you see here, we have all the data for mean, minimum value, maximum value, and standard deviation, everything about our data, right? And the count, the number of rows, right? So the next step is to visualize this data by using seaborn package, right? I have imported it as SNN, right? I have imported it as SNS, right? So SNS dot. We use a special plot here, that is pair plot, in which it will plot the graphs for all the variables, right? Let's see. Just run this, wait for some time, it will give us the output. Let's just observe each and every graph so we will be able to know which columns are having the relationships between them. If you see here, let's go to gold here. These are the graphs corresponding to gold and all other columns, right? So if you observe the pattern here, let's see the pattern here for gold and silver. It is of kind of positive correlation, right? The positive correlation is nothing but if one value is increasing, the other value is also increasing. Like in this case, if gold value is increasing, the silver value is also increasing, or else I can say the silver value is increasing, then the gold value is increasing, right? So here I can say it has less correlation and it is kind of negative correlation. You see the values are decreasing, kind of decreasing, right? But it has very less correlation if I say. And this SPX is kind of increasing and it has a positive correlation. So the positive correlation is nothing but if one value is increasing, the other values also will be increased. The negative correlation is nothing but the vice versa. If one value gets increased, the other value gets decreased, right? But it has some relation, then it is called correlation. If it doesn't have any dependency, then it has no correlation, right? So to see this correlation in the numeric format, let's use some method here, that is gold price dot core CORR. We use this function or method to get the correlation values. Let's store these values in correlation like that. Let's run it. I want to visualize this data using an heat map, right? So let's use this seaborn package again, using plot to define the figure size here. Fig size, let's say 8,8 like that, and I'm using the seaborn package here to draw the heat map. Let's send this information correlation values, and then I want to draw the correlation matrix, that is the heat map, with the square boxes. So let's say square equal to true like that, and then I want to annotate the square boxes. That means I want to write the correlation value on it, on the square box. So annote equal to true like that we can do, and I can give the color for this heat map also. Let's say I want to give the color it as green. I can give it as greens like that. Okay, let's run it. Sorry, my bad, it should be heat map, not heat map. Okay, run it again. So this is the heat map I was talking about, right? Let's zoom out a little bit. Yeah, you can see it more clearly, I hope. If you see the scale here, if your value is nearer to 0, then I can say it has less correlation, not the positive, not the negative. It has a very less correlation with the gold. Okay, and if it is close to 1, I can say it has more positive correlation towards the both columns is having the positive correlation, right? And if it is closer to the negative values, that is -1, then I can say it has the two columns has negative correlation, strong negative correlation, the more negative correlation. Okay, so 0 means it has no correlation at all. Nearer to 1, it is having strong positive correlation, and nearer to -1, it has strong negative correlation. Okay, so if I see here, for gold, the values for silver and gold, it is 0.87, right? So 0.87, if you see, it is very nearer to 1. So I can say the silver and gold is having more positive correlation. Even if you see in this graph, the gold and silver, this graph is having a straight line increasing, kind of straight line, right? So this is having more positive correlation between silver and gold. And if you observe, there are no much other correlations nearer to -1 or 1. This is the highest value, I can say. So let's sort the values for gold column, and let's see them, which has the more correlation and which has less correlation. I can say correlation of gold dot sort values like that, and ascending equal to false. Okay, let's run it. If you see, you have to leave the first column because it is a gold to gold relation. Okay, and let's see the second value, it is 0.86, which is nearer to 1 and having a very strong positive correlation, right? And if you see the negative value here, it is 0.1, negative 0.1. That is, it is not very close to -1, rather I can say it is very close to 0, right? So in all of these columns, I can say only silver is having more correlation with the gold, right? Anyway, let's use all of these columns to predict the gold price value. Okay, before that we have to divide x values and y values, right? So what are our x values here? You know, right? Except gold, all our values are x. You can take any other value, even single column or the multiple columns you can use, but I'm using all of these except gold because it is our dependent variable, right? That is the column values we are going to predict, right? So I'm using gold as dependent variable and all other variables as independent variables, right? So let's take gold price dot, I'm using drop function again to drop this gold variable, comma axis equal to 1, and for y values, gold price dot, I can take gold, I can take like this, gold values. Okay, let's print them, x values, comma y values, right? So if you see here, the x values doesn't have gold values, and this y values is having only the gold price values, right? So the next step is to split our data into train and test sets. Okay, for that I will be importing train test split method from sklearn. So this is where I said I will be importing few things from sklearn. Sklearn dot model selection import train test split like that. Then I can use this train test split function. I will be sending the x values first, then y values next, then my test size, right? What is my test size and the train set size? I will be using 20% data as my test size, so I'll be giving 0.2. So this will make a test size data set as 20% and train data set as 80%. Then, so the values which I will be getting here is x train and x test, y train, comma y test, right? Let's run it. Let's print the shape for these train and test data sets. Print of x train dot shape like that. Dot print of y train dot shape, right? Same as x test dot shape and then y text dot shape. Let's do this. So if you see 1832 rows as train data and 458 rows as test data, right? Pretty simple to divide it as a train and test sets, right? So the next step is to build our model. So first I will be using the inbuilt models that sklearn is having, and then let's build a neural network model afterwards at last. Okay, so So let's build this linear regression model first. Linear regression. Let's say, let me write it here. Linear regression. Okay, like that. For this linear regression, I have to import it from sklearn again. From sklearn dot linear model, I will be importing linear regression. Okay, so I have to create an object first. Linear regression, like that. You have to create an object, and I will be storing it in as, and I will be storing it in a variable linear reg, like that. And let's fit our data in this variable linear reg dot fit, and I'll be sending x train comma y train data. So I'll be training this data using this model, and the next step, let's print the score, how well our model got trained. So let's use this score method in the sklearn to print the score, right? So let's use this score method now. Linear regression train score. I can see how well the model got fitted. Okay, linear regression dot score of x train comma y train. I can even check it for test data also. Let's copy the same thing here in the next line. Change train to text. Here also x train to x test and y train to y test. Right. Let's run it. So if you see the score, it is pretty much impressive. 87% and 89%. Right. And let's use this x test data to predict our variables. So let's use this model to predict our test data. Right. Linear regression linear reg dot predict, like that, and send our text data here, and let me store it in linear reg underscore y predict, like that. Okay, let's run it. So let's see the auto score for this predicted data, right? Using the same sklearn, let me import the matrix from sklearn. I have to import auto score from sklearn, so I can do like this: from sklearn dot matrix import auto score. Right, let's run it. So let's use this auto score to print the prediction score, right? Let me use this auto score first. Auto score, this will take y test and the predicted value here, right? Let me store it in some variable like linear reg auto score, like that, right? Let me print it also, linear regression auto score, like that. Let's run it. So if you see, it is of 89%, right? So the score is 89%. It is not bad. I can say it is very close to 90%. Let's see. Let's also see the accuracy for this model. To see the accuracy, I will be importing one more thing from matrix, that is mean absolute percentage error. So mean absolute percentage error, right? From this mean absolute percentage error, I will be calculating our accuracy. Okay. So let's call this function, and I have to send y test, comma, our predicted values here. The same thing for auto score, we will do this, and it will calculate our error, right? So the accuracy can be calculated using this formula, 1 minus this error. So this is our accuracy. Let's print it first. So our accuracy for linear regression, right? Let's change this accuracy to accuracy linear reg, like that. Copy this, paste it over here, and let's run it. So for linear regression, accuracy is 95%. Okay. Then let's see another model here, that is the regressor. Okay. There are different type of regressors here, right? So I will be using 2 or 3 regressors here. So let's name it as regressor now. Regressor. Let's run it. So let me import 2 regressors from sklearn dot ensemble, right? From this I will be importing extra trees regressor, like that, and random forest regressor, right, like that. Let's run it. And our next step is to create an object, right? Initialize these objects. So extra tree regressor, or I can use some kind of parameters here. So let's say n estimators equal to, let's say, 100, and so I can give another parameter here, that is random state. I'll be giving it as 100 again, and for again the random forest regressor also, I'll be giving the same parameters, right, like that. And now let's store the extra regressor in extra reg, like that, and random forest as random reg. Okay, let's run this. Before that, I have to fit the model, right? So I can use this dot fit method to do that, in order to fit that, right? Dot fit x train again, comma y train again, like that, and random reg dot fit of x train comma y train. After fitting, I have calculated the score right here for train and test. Let's do the same thing here also, right? I'm copy pasting the same thing here. Let's copy the extra reg here, Right, like that. And also for random reg also, that is random forest regressor. For both regressors, I will be calculating a score for both training and testing data. Let's see. It is fitting the model. So if you see, I think I have to change the names, right? Extra, random, random. Let's see. Hooray! You see here the training reg train score, it is 1. So it is saying that I'm 100% sure the fitted model is more accurate. And here the values are pretty much impressing more than the linear regressor, because if you see the values are more close to 1, that is 100%. Here it is 99%, 99%, and this is the training score is 1, and like everything is kind of closer to 1 or 100%, right? Let's use these models to predict the values and calculate the accuracy first. So let's take extra reg dot predict of x test, like that. Copy it. Do it the same for random reg also, that is random forest regression. Let me store these in a value random reg underscore y predictions, right? In the same way, random reg underscore y prediction. Run it. So let's calculate the auto score for this. Let me copy the thing here. From linear regressor, I will be copying this. Let's change the values. So instead of this linear, I will be giving it as extra, like that. Copy it, paste it over here, extra, right? The same thing I have to do it for a random forest regressor also. Random, random. So let me change it to random again. Let's run it. So if you see the auto score, it is also closer to 100%, right? Let's see the accuracy. I can't wait to see the accuracy for these models, right? Copy this, paste it over here. So let's see accuracy for both of these models. Copy it, paste it over here. Accuracy of extra reg, right? So extra reg. Let's copy the same thing again, paste it over here. Change everything to random again. Random, random. Run it. Hooray, the accuracy is, if you see, the extra regressor, it is having 99% accuracy, and the random regressor, it is having 98% accuracy, right? Let's run it. Change it to random. 98% accuracy and 99% accuracy. So let's see another model here, that is SVM, or like SVR, I can say. So let me do it quickly. Support vector regressor. So from sklearn .svm support vector missions, I can import SVR, like that. So for this one also, I want to create an object here, SVR. This has a kernels. So let me give one kernel here. I can say I will be giving a linear kernel here. You can use anything based on the need. You can see the documentation in the sklearn website. SVM dot. I'll be fitting the model using this train data. Y train again. Let's print the train and test score. Again, copy paste the same thing. I'll be doing the same thing again and again. Instead of this extra reg, I can give SVM. SVM. Here it also SVM. SVM. Okay, right. It's taking some time. As it is running, let's copy the few things from here, as we will be doing all of them again. Predicting, right? And then we'll be finding the auto score. Then we also do this accuracy. Right, let me change the variable names. I can use SVM, like that. SVM. 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 So it took a lot of time, but the accuracy is not as promising. If you see, it is having a 84% and 87%. I hope this score is not much as our extra tree regressor and random tree regressor, right? Let's see the accuracy anyway, right? Let's run it. Oh, but the accuracy, if you see, it is 95%. Yeah, of course, because this score tells us how well the data got fit into the model, not the accuracy, right? This is the actual accuracy, that is 95%. This is also good than the linear regressor, right? So let's add up all these regressors and make a data set, that is data frame, so we can find which data predicts the more correct values, right? Let me do this. So I will make a data frame here using pandas. Data frame of, I have made 4 models here, if you observe, right? So I'll be appending all the predicted values in this data set, data frame, actually. So I can do this linear. I can actually copy these values, right? The prediction values. Copy this, paste it over here. This makes the thing easier. and then the second one is extra regressor, right? So let's take extra regressor and also the random regressor. I have to copy the predicted values, right? So change it to y predict like that, paste it over here. Okay, so at last I have used this SVM, right? So copy these values, prediction values, paste it over here. Oops, copy this, paste it here. So I'll be storing this data frame inside let's say prediction predicted data frame, like that. Okay, let's run it. So if you want to visualize this data frame, let's see what is the data. So this is the first 5 rows. If you see, this is the before that I can append the actual values also, right? So let me append the actual values also. It is easier to compare with the predicted values. So y test, right? So let's do this. Let's see now. So if you see, these are the predicted values for these 4 models, and this is the actual y test value. So you see, this is 152, and the random regressor got it correctly, that is 152, right? And the second one is 108, and the extra regressor got it as correct 108, but the random regressor is also close to it, 109, I can say. So I can say this extra regressor and random regressor, if you see, their accuracy is 99 and 98, right? So they will be predicting more accurately than other 2 models, that is linear regressor and SVM, right? So to find the best model, let me create a for loop, right? For IND for indexing prediction df dot index, I can say for each index here I'll be taking all the values of that row, right? So let's do this. Prediction df dot index, it will give me the index value, and if this is equal to IND, that is the index value in this for loop, then I'll be taking that whole row data like this, and I'll be getting the values by doing this. I'll be getting 2-dimensional array. So I have to convert it to 1-dimensional. I can do that using like this. I'll be accessing the first element. So this is 1-dimensional array again. I'll be converting them to an array, that is numpy array, so we can do the operations easier, and let me store it in prediction values like that. Okay, so what can I do now is, so how can I find the best model here, right? So I'll be taking difference for y test and all other models here, and whichever gets the less difference, then that model wins the row, right? So let's do this. So I can say the predicted values again. I can copy the same variable here, because I will be calculating the difference here, and we dot I will be calculating the absolute difference here. So whether it is high or low, it should have it should be close to this y test, right? So the closer value to the y test wins the race. Okay, so predicted values of, I can say I will be taking all other values except lost value, and I will be deleting this lost value from these previous values, because if you observe here, the lost value here is y test. I have to take difference between y test and all of these values, right? So by using numpy, I can do this. I'll be taking all values other than the lost value here until -1. So it takes from here to here, and then I will be doing a subtraction here. So I will be subtracting y test from all other data here, and I will be storing it in the same variable predicted values, right? Now the best model I can say is which is having the less, that is minimum difference, right? So I can do this np dot arc main. So it will return me the index value for the minimum value. So you can ask me why the index, not the value. So I can't do anything with the value, right? For the index, I can find what is the best model here. So if it returns a 1, I can say it is extra reg, and if it returns 0, I can say it is linear. If it returns 2, I can say it is random regression. That means the race for that row, right? So I'll be taking this index, and from predicted df dot columns, I can get the column names here, and I'll be getting the index here. So I got the column which is the best model. Then let's take a list here, best model, to store our best models. So paste it over here, dot append end. Okay, so at last let me append this best model to this. So in each row I can say which model wins the race. Okay, like that, right? So let's see the data now. Predicted df dot head. So if you see here, it is clearly visible the best model for first row. It is a random regressor, and second row is extra regressor, and the third is random, and then extra. Let's see which model predicts more values correctly, right? I can do that. It is very simple. Prediction df dot, there is a special function called values count. So it will calculate the values, like it will aggregate all these values and count the number of times they repeated in the row. Okay, so dot best model dot value counts, like that. Let's see now. So if you see the extra regressor, it is showing 234. So it predicted 234 rows correctly. Not only 234 rows, it predicted every value, but 234 rows is more closer to the actual predicted values, right? And random regressor, it is predicting 158 rows, which is closer to the actual value, right? Like that, if you see, the best model is extra reg, that is extra tree regressor model. Okay, so let's not only stop with these models, let's create an artificial neural network model where we can see whether that deep learning model will give the accuracy or not. Okay, this extra regressor got us to 99% accuracy. Let's see. Who knows? Oh, the artificial neural network might work very well than these models. Okay, let's see. So to create the artificial neural network model, I will be importing quires and the sequential layers and dense layers from TensorFlow. From TensorFlow dot quires dot models, I will be importing sequential like that, and from TensorFlow again dot quires dot layers, I will be importing the dense layers. Okay, so let's create this neural network model. Let's initialize this model using the sequential, right? This should be capital S, like that. Let's initialize this neural network model. So let's use this dense to add up the hidden layers, right? Let's add 2 to 3 hidden layers here. Dense of, I have to give the number of neurons in the layer. I can say, let's say it having 10 neurons, and I have to give the activation layer, the activation function it should be using in this layer, right? That is ReLU. I'm taking it as ReLU. There are other many more activation functions. You can use any of them, but in this case I'm using this, and input dimensions as 4. Then the next layer I'm using is also the dense layer of, let's say, the same 10 neurons and the same activation function, ReLU, like that. And I will be adding the last layer, that is the output layer, with a dense, that is also a dense layer, with only one neuron, that is the output neuron, with an activation function of, let's say, linear. Okay, you can use any of these activation functions anywhere in the layers, but whichever gives you the highest accuracy, you can use that. It is the trial and error method, like that. Model dot compile of, here I have to give, like, to compile this model I have to give few parameters like optimizer, right? Optimizer, and again here there are many optimizers. You can use any of them. I'm using Adam here. And the loss, you can use this parameter to calculate based on which thing you have to compile this. Like, I'm using loss. To decrease this loss, we have to do the model building, right? Mean squared error as my loss, right? So at last, let's see the summary of the model. Let's see. After this, we have to fit our model. This is not yet done. Let's see. If you see, the first layer is dense layer and it is having 10 neurons, and the second layer is having the 10 neurons, and at last the output layer is having only one neuron. That is the output layer. That is the output neuron. Okay, so let's fit our model using dot fit method again. Dot fit. I'll be sending the x train, y train, and here the some other parameters, that is we call it as epochs. So this, what is this epochs? In the sense, it will take the training data and it will run through the model these many times. These many times is nothing but the number of epochs. Okay, I'm giving it as 1000. So the data is less. You can give as higher value as it is. So you can train faster. If data is huge, even if you give a less value for this epochs, it will run. It will take a lot of time to run or build this model. So use it as required. And there is one more parameter, that is validation split. Validation split. So for validation split, I will be using 20% data rate. So I'm giving this parameter here. Nothing fancy here, and I'll be storing it in the history variable. Let's run it. It will take some time to run. Oops, I got an error. Mean square error. Okay, the spelling is wrong. I can do test like this. So let's run it. Now it is building our model. So you see the epochs are running 10, 11, 12. It will take some time. Let's see how much time it takes. So if you see here, guys, this model is getting completed. 50 more runs. And if you see the loss, it is gradually decreasing. So after this model got completely built, so let's plot a graph now at which epoch it is giving the best model, right? So to do that, we have to take the model loss here using the history dot history. Inside this history variable, we'll be having an history dictionary in which we'll get all these values loss and also the validation loss. History dot history validation loss, like that. And using this validation loss and the model loss, let's calculate the at minimum at which index the model got less loss. That is the minimum loss. Okay, let's calculate that index value where it got minimum loss using this numpy. It will return the index value for it, where I can use it for plotting. So using this np.argmin, I will get the minimum value index, and I'll be storing it in an index loss variable, right? Validation lowest value, that is val loss, index loss, and epochs for I in range of length of tr loss. Okay, and also for labeling these epochs, I will be taking loss label like this. So I'll be labeling the best epoch here using this loss label. Okay, index loss +1. Let's plot the graph here. PLT dot figure of fixed size equal to, let's say, 20 comma 8, like that. Let's plot PLT dot plot epochs comma year loss. Let's give it a color that is red and label it as training loss. Okay, let's plot another thing here, that is the validation loss, right? So the training loss, it is nothing but the model loss here, validation loss, like that. Let's plot a scatter plot also here. So to plot the best model here, index loss. So I will be plotting the best model using the scatter plot. This is the value, the lowest loss value, and I am giving it a size of 150, so it will be visible in the graph. I will be giving it a blue color and label it as loss label. We have defined it earlier, right? The same thing. That is the best model, like that. Let's give title for this graph: training and validation error. Okay, let's say loss, like that. And let's say X label as epochs and Y label as loss. Let's also give legit to this, so we can differentiate which line is corresponding to which one. Plot dot show, like that. Let's run it. Let me change it to single quote training. Sorry, my bad. This is training loss. I can say it as model loss. It's running. Let me give it as green here. It's running. So if you see this graph, the best epoch is 992. It is having the lowest loss, right? Okay, let's use this model to predict our values. Model dot predict. Let's calculate accuracy afterwards again. ANN Y predict, right? Let's calculate R2 score. ANN R2 score equal to R2 score of Y test, comma, the predicted values. Let's print the R2 score here. It is 93%. Let's quickly find the accuracy. Let me copy from here. Right? I'll be pasting it over here. Changing all the values. ANN. Let's run it. Let's see how this artificial neural network got trained, how well it got trained, and what is the accuracy for this model. So it is 96%, if you see. So the highest accuracy we got is for extra tree regressor, and it is 99%, and it is 99% accuracy if I'm not wrong. Yes, it is 99% accuracy. So this is the super model we got it today to predict the gold price values, which is having 99% accuracy. You try to build these models again. Let me know in the comments if you get 100% accuracy for any model. Thanks for watching this video. If you have any doubts, please feel free to comment down. Please subscribe and stay tuned for more videos. Thank you.